chronic disease burden is a growing problem in the US, with 70% of all healthcare resources spent on patients with one or more of the top 10 chronic diseases. My name is Marc van Zyl, and the goal of my invention, Athegia, is to address some of the biggest barriers to effective treatment of senior citizens in chronic diseases and other patients with multiple conditions. The cost of treatments and death can be significantly reduced if patients are treated in closed-loop protocols where key biometric readings are taken and uploaded to the cloud where they can be reviewed by doctors, and corrective actions can be taken to keep those diseases under control. In recent years, there's been a massive increase in cheap biometric sensors that connect through phones to the cloud and can measure almost every metric available about your body. There in the cloud, they can be analyzed by doctors and healthcare workers. So, is this problem then solved? Unfortunately not. While the technology has improved considerably, the behavioral challenges remain, and my invention will help address this. Consider the largest segment of people affected by multiple chronic diseases, senior citizens, and about only 50% of them have smartphones. Many of those that don't, like my grandmother, struggle to use anything but the most basic of apps. Imagine the challenge in getting them to use 4 different biometric sensors, each with their own app. In order to solve this problem, I decided to create a platform, a single device that can monitor and connect to multiple Bluetooth sensors with a common and familiar user interface. I would leverage the current innovation in sensors, but create my own system for secure collection and processing of the data. For my first iteration, my design was a very simple to use mobile phone app that could read multiple Bluetooth sensors. But after interviews with senior citizens and seeing my grandmother struggle to pair a Bluetooth device to her phone, I realized I needed something much simpler. I was inspired by the story of how Steve Jobs created the iMac by designing a computer to resemble a simple appliance. My second major iteration was along these lines. The device shouldn't be out of place in the kitchen, be no more complex than a toaster oven or kettle, be integrated with their daily lives like making a cup of tea in the morning, and must be so intuitive that they can just naturally understand how it works. I decided to create a preliminary prototype for the physical design. I used a 3D printed case with a Raspberry Pi as my processor and a touchscreen as the interface. It was quite easy to create a simple interface in Python with the PySimple GUI library, but the big challenge was connecting current Bluetooth devices and reverse engineering the interfaces and protocols to control the sensors and read their data. I did this using the Bleak Python library. Once I was able to read the data, the Raspberry Pi could save it to a secure database on the Google Cloud platform. When I demonstrated this device, I realized it still wasn't simple enough, and in order to create these habits that I needed, I had to find a way to insert it into the schedules of these senior citizens using habit stacking techniques. The first thing my grandmother does walking into the kitchen every morning was looking at her weather station in order to plan her day. For my third major iteration, I designed a configurable landing screen to my UI that could be customizable to different patients. For my grandmother, I created a weather screen. I also redeveloped the Bluetooth system to enable a much more simple and intuitive experience. The hub would continually scan for known sensors, and as soon as the user switched on one, would automatically start the connection and reading data process. The final change was to replace the clunky Python user interface with a JavaScript web-based interface which supports customizable landing pages. All my code is available on GitHub with a link in my logbook if you want to see it. Now let me quickly demonstrate the system with one of my 3 sensors. So, as of now, this hub is scanning for devices, trying to find any of those that are connected. Once I turn my pulse oximeter on, it's now connected, and as we can see in the bottom corner, it is found by the device. Then, once it starts receiving data, it gets displayed on screen, and when it's finished, it goes to light gray to tell the user that they are done with that device. Other than this pulse oximeter, I also have a blood pressure monitor and a temperature sensor connected, and I'm currently working on a scale to connect. My target markets are health insurers and doctors treating patients under performance-based contracts. I could build my device for less than $300. With higher production, this price could be decreased below $200. The details of manufacturing are in my logbook if you want to check them out. I plan to price the hub at $400, which may seem high, but it's actually quite cheap considering that it would save more than $7,000 every time a patient is hospitalized. There are 32 million senior citizens with chronic diseases currently in the US, and even if only 30% of the market was interested in my product, I have a potential profit of $960 million. My next step is to redesign the physical enclosure to be more appliance-like, with rounded edges in the retro style of the 1950s and 60s, and to test this device with some patients. Thank you again for considering my invention. And with Athegia, I believe we could overcome some of the biggest technological and behavioral barriers to make the management of chronic diseases more effective and bring comfort to millions.